Imagine a world 5 times the size of Jupiter, hurtling through space at 500,000 miles per hour, with a magnetic field so powerful it could strip away Earth's atmosphere from millions of miles away. This isn't science fiction. NASA's latest discovery has astronomers worldwide holding their breath. Welcome back to Beyond Space. Where we explore the universe one mind-blowing idea at a time. Today we're diving into what might be the most intriguing and potentially unsettling discovery of the year. NASA's team at the Transiting Exoplanet Survey Satellite, or TESS, has detected something extraordinary, a rogue planet with characteristics that have never been seen before. Before we explore this cosmic beast, hit that like button if you're ready to learn about one of the strangest objects ever found in our galaxy. And stick around until the end to hear why this discovery might change everything we know about planetary formation. Picture this. While mapping a seemingly empty region of space, TESS detected an anomaly, a massive object moving independently of any star system. But what made this discovery truly extraordinary was what came next. Let's break down why this planet is unique. First, its incredible magnetic field is off the charts. We're talking about a field strength thousands of times stronger than Earth's. This massive magnetic field is creating what scientists call a cosmic hurricane, a swirling storm of charged particles that extends for millions of miles. Now, here's where things get interesting. This rogue planet's orbit appears to be unstable. While it's currently thousands of light years away, its trajectory suggests it's been ejected from its home system. This raises a fascinating question. How many of these cosmic wanderers are out there, silently drifting through the void? And that leads us to the heart of today's video. What exactly is a rogue planet, and why should we be worried? Rogue planets, also known as interstellar or nomadic planets, are celestial bodies that do not orbit a star. Unlike Earth, Mars, or even the gas giants in our solar system, these planets are drifters, cosmic loners expelled from their home systems due to violent gravitational encounters, supernovae, or even ancient galactic collisions. NASA and other space agencies have theorized about their existence for decades, but it's only recently, with the advancements in infrared and gravitational lensing technology, that we've been able to detect them. What makes this particular rogue planet so unique isn't just its size or speed, but its threat potential. You see, most rogue planets are cold, dead husks, dark giants frozen in the abyss. But not this one. According to preliminary data, this planet, currently nicknamed Hyperion X by some within the scientific community, is estimated to be 5 times more massive than Jupiter. That makes it one of the largest free-floating planets ever discovered. But more astonishing is the heat signature it's giving off. Despite not orbiting a star, Hyperion X emits a faint but consistent infrared glow. This suggests one of two things. Either it's still radiating leftover heat from its violent formation, or something is generating internal energy, possibly a core made of exotic matter, or even radioactive decay on a colossal scale. Its magnetic field is something straight out of a science fiction novel. For reference, Earth's magnetic field is measured in microteslas. Jupiter's is roughly 20,000 times stronger than Earth's. Hyperion X? We're looking at a magnetic field potentially millions of times more intense. Such a magnetic field isn't just impressive, it's dangerous. This field could theoretically bend and twist the interstellar medium around it. In simpler terms, it's creating a storm of energy in every direction as it speeds through space. Now, let's talk about the scenario no one wants to consider, but we must. What happens if this rogue planet doesn't stay on its current path? Although current models place Hyperion X thousands of light years away, its trajectory is unstable. It's possible that in millions or even thousands of years, it could drift closer to our solar system, and if it does, it wouldn't need to crash into us to wreak havoc. Thanks to that monstrous magnetic field, it could begin stripping away our protective magnetosphere from afar. Earth's magnetosphere is what shields us from solar radiation. Without it, the sun's rays would fry our atmosphere, causing mass extinction and turning Earth into a dead rock, just like Mars. Think about that for a moment. A planet we may never even see with the naked eye could silently wipe us out by simply passing nearby. Let's rewind and give some credit to the science behind this discovery. The Transiting Exoplanet Survey Satellite, or TESS, is primarily designed to look for exoplanets by monitoring the brightness of stars. When a planet passes in front of a star, what we call a transit, TESS detects the resulting dip in brightness. But rogue planets don't transit stars. So how did TESS find this one? That's where things get fascinating. This rogue planet was actually detected through an unusual lensing event. As the planet passed in front of a distant star, it bent the star's light, a phenomenon known as gravitational microlensing. The amount and duration of the bending gave scientists an idea of the object's size and speed. And what they saw didn't match any known exoplanet catalogue. The data pointed to something massive, fast, and completely untethered, a ghost planet, screaming through space. Since the announcement, scientists have been scrambling to figure out where this thing came from. One theory suggests it was ejected from a young star system after a close encounter with another massive body, possibly a binary star or a black hole. Another, more controversial theory? Hyperion X could be a primordial planet, formed not around a star, but directly from the gas and dust of the early universe, making it older than any known solar system. There's even talk in fringe circles about it being an artificial object, a construct of some advanced civilization. While NASA has not entertained this idea officially, you can bet it's been whispered in some late-night observatories. So let's bring it back down to Earth, literally. Is Hyperion X going to destroy us? Should we be panicking? The short answer, not yet. The long answer, it's complicated. Space is vast. Even at 500,000 miles per hour, this planet would take tens of thousands of years to reach the outskirts of our solar system, assuming it's heading our way at all. But it's the unpredictability that's unsettling. Rogue planets don't follow the neat elliptical paths we're used to. They're chaos incarnate. One gravitational nudge, one stellar encounter, and their path could shift dramatically. Hyperion X is also forcing scientists to rethink planetary formation itself. Until now, we believed that planets form from the leftover material orbiting a new star. That material clumps together over millions of years, eventually forming rocky worlds and gas giants. But rogue planets like this one suggest there may be other pathways, alternative blueprints for how worlds are born. If Hyperion X truly formed outside of a stellar nursery, then our understanding of the galaxy's architecture is incomplete. There could be billions of these things, undetected, undocumented, and drifting silently between stars. And here's the kicker: they may outnumber stars themselves. There's a sobering beauty to this discovery. It reminds us how small and fragile we are in the grand tapestry of space. We've spent centuries mapping the skies, plotting the movements of celestial bodies, and trying to predict the future. But this rogue planet is a reminder that the universe doesn't play by our rules. We are floating on a pale blue dot, protected by a delicate atmosphere, warmed by a single star, and now we know that at any moment, a wandering giant could knock on our galactic doorstep. But we're not powerless. This discovery highlights the importance of investing in space science. The more we understand about rogue planets, cosmic radiation, and gravitational dynamics, the better prepared we'll be for what lies ahead. Projects like TESS, the James Webb Space Telescope, and future missions will help us track and maybe even predict these interstellar threats. And who knows, maybe one day we'll find a way to move Earth, build planetary shields, or escape to safer stars. But first, we need awareness. We need knowledge. And that's why discoveries like Hyperion X are so critical. Imagine this. It's 3 a.m. in a deep space observatory. A lone astronomer stares at data streaming across a monitor. A spike, a shadow, a trajectory deviation. A once stable path now curves slightly inward, just a fraction of a degree, but enough to raise questions. Suddenly, the numbers don't match up. What if Hyperion X is not just wandering, but spiraling? This is the scenario that keeps astrophysicists up at night, because in a universe where even tiny gravitational shifts can have colossal consequences, a rogue planet's path is never guaranteed. And if it is spiraling in our direction, even over a time frame of thousands or tens of thousands of years, then the clock has already started ticking. Hyperion X could be the harbinger of a new kind of cosmic threat, one we can't see until it's too late, one that doesn't come with fire and noise, but with silence, distortion, and electromagnetic annihilation. It wouldn't just destroy satellites or power grids. It could rewrite Earth's climate, alter magnetic poles, collapse GPS networks, render entire continents blind to communication. It wouldn't be an impact event like an asteroid. It would be an invisible war on physics itself. And perhaps the most terrifying part, we still don't fully understand it. But this isn't a doomsday message. It's a wake-up call, a cosmic telegram sent across light years, reminding us that the universe is not just a backdrop to our lives. It's alive, it's dynamic, it's dangerous. Yet within that danger lies wonder. Because for every Hyperion X that could pose a threat, there might be dozens of others carrying secrets of the early universe. Rogue planets could hold ancient compounds, long-lost materials, or even hidden oceans buried beneath thick ice crusts. Some scientists even speculate that rogue planets could harbor life, not on the surface, but within. Imagine a world where heat comes not from a sun, but from radioactive decay at the core, warming an underground ocean protected from the cold of space. In that black abyss, simple life could be evolving right now, unaware of the stars, unaware of us, just as we were unaware of it until now. The discovery of Hyperion X marks the beginning of a new era in space exploration, an era where the objects we fear may also become the keys to understanding the universe itself. New missions are already being proposed to map the interstellar medium in greater detail. Advances in infrared telescopes, gravitational wave observatories, and space-based particle detectors will soon give us the ability to spot rogue planets earlier, and maybe even predict their paths centuries in advance. And who knows, perhaps in the not-too-distant future, we'll send probes to these worlds. Maybe one day we'll land on one. And maybe, just maybe, we'll find answers to the biggest question of all. Why are they out there? Because if there are rogue planets, there are rogue histories. Stories written not in books, but in gravity, ice, and magnetic storms. And now that we've found Hyperion X, the first true monster of the void, we have a responsibility to keep looking. So, are we prepared? As a species, not yet. But that's the beauty of being human. We grow, we adapt, we push forward against impossible odds. When the first astronomers looked to the stars thousands of years ago, they saw gods and myths. Today we see rogue planets, galaxies, and the birth of black holes. We're learning the language of the cosmos, one discovery at a time. And Hyperion X is speaking to us, loudly, urgently, not in words but in mass, magnetism, and momentum. It's telling us that the universe is far more complex, far more dangerous, and far more alive than we ever imagined. But if we listen closely, and if we respond with curiosity instead of fear, then this moment, this discovery, could be the turning point. The moment we stop being passive observers of the universe and start becoming true cosmic citizens. If this video blew your mind even half as much as it blew ours, make sure to hit that like button. It helps us reach more space lovers like you. And if you're new here, consider subscribing to Beyond Space, where we explore the wildest, most mysterious corners of the cosmos every week. Drop a comment below. What do you think Hyperion X really is? A natural phenomenon? An ancient traveler? Or something artificial? And don't forget to share this video with someone who still thinks space is boring. Until next time, keep your eyes on the stars, but don't forget to watch your back. Because the universe doesn't just surround us, sometimes it comes for us.